quick reminder in our Discord server. Nikita's Discord server as well. We are live. We are live. I hope people will get right. We are live. It does mean that we, yes, just alive. Hope they will get it right. Okay. Where is our SS Telegram? Please feel free to join. No, okay. Feel free to join. Okay, so no one yet. Okay, it's 3 minutes. Okay. Anyway, I think you can. Yeah, let me check our streams real quickly. If we are real, yes, we have a stream in Nikita's channel in YouTube. I hope it's yes. I'm checking my TikTok stream. Sometimes I noticed even Nikita started. Oh, did I get some? Do we have someone joined us? Okay. Yep. Okay. I see Artyom is here. Okay. Hi, Artyom. Okay.
Hi.
Okay, great. Let me real quickly check our live stream in Twitter. And in LinkedIn. Yes, we have someone else. Yes. Oh, Dean is joining us. It's really great. Hi, Dean.
Hey, how are you?
Great. Hi, Bilal. Hello, guys. Hello, everyone. Okay. Well, I think we have a big, like, a lot of us already joined, so I think we can start. Briefly speaking, like key speaker of our meetup today is Douglas. I hope Douglas can tell a couple of words, mostly to introduce for everyone, but for our team as well, and can tell a couple of words about topic of our meeting today. I can give a quick spoiler. Main topic will be dedicated to Docker, Dockerization, and similar questions. Okay, so you can, I think. Before this, if anyone have some updates, something urgent, or want to say something, ask something, have some ideas, suggestions, complaints, you can share it. In other case, you could wait until we can wait until the end of a session, and then we could discuss other, even unrelated topics as well. So, last chance to ask something urgent.
Looking forward to getting into it.
Okay, so if everyone is ready, let's start. Douglas, it's your place now.
Okay, all right. So first thing is, we tested this a little bit before, but I just want to be sure that I'm coming through loud and clear right now. Awesome. Okay, so like Mikola said, we are we're going to talk about Docker today. It's not, it's not going to be super in depth, as in we're going to go over everything. This was more of a, if you haven't had exposure to containers, I'm I'm trying to put something together to help people in that situation, right? What are these containers? The whole inspiration for this meeting was the fact that I've had some employees, colleagues on my team that we heavily use containers for our day-to-day work. In fact, I sit in a container uh, all day, every day, and do work from within a container. And I know that kind of breaks the rules of containers a little bit. If you are very familiar with it, you usually wouldn't want to do that. But I'm actually in a container all day doing work, so I'm really familiar with having the different layers, all over, that we have to think about to get our work done. Am I in my on my bare metal? Am I in the virtual machine that I actually am running Docker in, or am I am I actually in my container? And sometimes that's very confusing to new people that come. So this is kind of an introduction of the whys. Why are we, why in the first place do we even worry about this? I do want to demonstrate a couple of things around the power of having containers and how they make our lives as developers a lot more convenient. And then we'll look at some demos and see how this works. And we're going to start from some really simple stuff. And I didn't have a chance to put the complex demo together that I was considering, but I have some ideas that we might try just off the cuff to show that we can really do some interesting things with Docker and with containers as a whole. So, little bit about me. First of all, you can see my name down at the bottom of the screen. I'm Douglas Hirsch. I have been in software development uh, for over 22 years, actually, and I've started off doing a lot of different things before I got paid to do it professionally. But professionally, I started off in .NET and spent a lot of time in .NET and C Sharp. And then about 5 years ago, no, maybe 10 years ago, things got a little bit shaken up. I've done some Java now. I'm working in Python for my full time job. So I've been all over the place as far as that's concerned. Okay, that's about me. Let's go ahead and get started. So again, no fancy slideshow, but we're gonna try a couple of things and see how it works. All right. So I guess the first part of this is kind of let's take a look at the past and kind of come up here to the present day. I'm gonna switch scenes here. Hopefully that's not too jarring for anyone. Y'all should all be able to see a VS Code instance and a diagram sitting in the middle. And this is kind of what I want to use to go, from where we started, especially when I got started in the field, the companies that I went to, you would see that they had the big server, right? They had the man, I hope nothing happens to this thing because it's all configured properly, and that's a bad thing. So let's go ahead and I'm going to start from the bottom here. So in essence, you know, really the way that things worked at first. The sandcastles, absolutely. Yeah, that's a great comment. They really are like sandcastles. I've built sandcastles myself before I even got into the professional world. Um, so if something happened to it, it's gone. I have to spend days trying to get it back up and running again. But let's start from the bottom here. And the bottom is the hardware, right? We've got some hardware that's going to be, the typical CPU, RAM, hard disk, all of that stuff, bare metal hardware, right? That's why we call it bare metal at that point, because we're sitting right on the hardware. Then the next thing is the operating system, right? That's whether you're running Windows, Linux, whatever it is, anything that any operating system that you need to run. In fact, from being on the Microsoft shop side of things when I first got started, that would have been Windows Server, right? And then if you did things in the Linux world, of course, that would be Linux or whichever operating system that you needed to run. Now, here's where things get fun or not fun, as I've mentioned before. Yeah, Dean, it was kind of the same thing for me. It was pretty late. It was probably maybe 2014, 2015 before I got to where I could do anything at that point. Usually it was Microsoft job after Microsoft job. But anyway, back into this sandcastle here. So the thing is that we would build applications, and after we were done building it, we would create some kind of artifact, whether that would be assemblies from .NET or whether that would be jar files in Java, whatever it is that whatever artifact it was. And then we would ask someone in operations to copy our stuff over to this bare metal server and then try to start it up for us, right? So it would run. And, a lot of times there'd be some successes and sometimes there wouldn't be. But what made life really complicated is the fact that as you can see in this example here, I don't think this is too far off from reality. There's the web server, maybe they've got like 10 different web applications running on it. Maybe there's some web services running on there and, probably a database. Maybe even 2 different kind of database servers running on there. Maybe you've got Mongo and you've got a relational database of some sort, Postgres or, a Microsoft World SQL Server, right? So, here's the problem though. Not only do we have a sandcastle where one thing, where if the server goes down, you're going to spend days trying to get it back up and running again. Because sometimes those backups don't just get us back to where we should be. And sometimes the IT operations doesn't make the backups like you think they should. So, excuse me. That's right. Sometimes they will, and like if the server imploded completely or exploded, depending on I've heard stories, you know, then you are. That's a really good point, Dean. That backup usually will only work with one type of hardware. So you could get stuck trying to put everything back together, build the sandcastle from scratch on a whole new set of bare metal hardware. And it really does. It really is high risk. I mean, if you could be down for days if you weren't set up right. So the other problem, though, is that maybe one of those web applications has something in the environment that is causing problems with other web applications, or maybe some developer made a new change that did introduce something into the environment or a conflict and a dependency somewhere that really is causing some nightmares to occur. Or instability where it just takes the whole server down because the new application or the update to the application caused an instability of some sort. So again, major disadvantages. The only advantage that I feel that you have at this point is that you get all the performance, right? There's no intermediary layers. There's no virtual file systems, no nothing. Nothing that sits on top of the CPU and anything. It's just bare metal raw access to the operating system and the underlying hardware at that point. But again, with everything in computers, there really are no 100% solutions. There's always trade-offs, right? You always have to weigh the trade-offs that you're going to make. And then I would say from here, there was a really cool concept that was created, right? This really cool concept. And y'all, you're going to think I'm crazy, but I actually my father was in software development. He did a lot of work at IBM. And so I had some access to some things that maybe not everyone did. And I had access to one of the initial versions of VMware. I think it was even a beta. And I had already been writing code. I started writing code when I was 12. So I'd already built, I already found conflicts even in my own development environment. If I got PHP running, don't hate me, but if I got PHP running and I was also running Visual C++, and doing stuff in there, and so I was already like littering my environment, my operating system environment with all sorts of stuff, right? And it at some point you could actually have weird things happen. So when I saw this concept of I could run a computer inside my computer, now mind you, my hardware back then was extremely limited compared to today. I mean, now I'm sitting on a laptop with 64 gigs of RAM in it. I can do a lot on this laptop. I could run a few VMs here. But, the thing is that the isolation was what I was looking for. I wanted to be able to say that I'm working on this project and be able to boot up a VM. I didn't need to run them all at once. I just want to, I built like isolated sandcastles at that point. The way you put it, Dean. It's that was it, but they were reproducible at that point because I could back up the virtual hard disks, and then I could bring them back up again if if I needed to. That was one of the advantages of virtual machines. So let's take a look at let's go into virtual machines and talk about that for a second. So with VMs though, here's what we get. We have a hypervisor, right? And that when I use the word hypervisor, if you've ever used a program like VirtualBox or VMware or any of those, that's kind of what I'm talking about here, right? A KVM, right? KVM and QEMU, yeah, absolutely, absolutely. In fact, I'm on a Mac right now, so basically, Hyper-V, yep. Those are all examples of hypervisors. Yeah, absolutely. I was just going to say that my Docker has to run within a VM that's managed by Docker Desktop because of the fact that Mac OS does not natively support Docker, which is okay. But again, that was an aside. Let's get back into this. So hypervisor, right? Well, the hypervisor is the layer that now becomes this emulation, you would say. It does do some pass through, but there is that point where you're jumping through the hypervisor to get to the hardware. And there's been a lot of improvements in virtualization from the hardware side of things. So it used to be that everything was emulated. There was no direct access to the hardware. The hypervisor had to make all, emulate everything for you at that point. But now with the way the CPUs have been put together, at the CPU level, we absolutely now have a much better performance than we did before. We can get closer to native performance, but it's not one for one. It's not 100%. Okay, but here's the other thing that happens. The hypervisor has to make it look like there's a whole computer for each of these VMs, which means that you have to dedicate some RAM to it. You have to dedicate some hard disk space to it. And if you need GPU, you're going to dedicate some of your graphics to it. I mean, there's a lot going on. It, in essence, has to make the underlying virtual machines think it has a full computer. And so that was, it was really cool, especially when I first used virtual machines, right? That I could have that isolation and I would start one up and then, I'm done with one project. I would close it down. Maybe the other VM had Visual C++ in it. Nothing from PHP and MySQL or any of that was sitting in that VM. And it was magical to me. But Again, I was having to run a whole computer inside my computer, which is what we see here. Resource utilization is one of the disadvantages. Isolation is one of the advantages between it. Now, we also started to see some portability because guess what? If the VM ran, if you had the virtual hard disk, you could now hand out full-blown development environments to your team using virtual machines. In fact, one of my positions back in 2010, I had to go that route because every install, it was a very complex development environment that we put together, having to do with an enterprise grade content management system, and it just every computer I tried to install it on for the team, it was a different install process. I could not give them one set of instructions. I had to always figure out my way around problems getting it on all their machines. So eventually, what I did is I decided that I was going to put together a virtual machine that was the pristine development environment, and then take that pristine development environment, virtual hard disk, and take it to all the other developers and go, here you go. And if you ever, if you break anything, just get this thing again and go and pull your stuff down from source control. You should be good. So isolation, reproducibility. But again, here's the other problem. Look at the amount of disk space that each of these takes up, right? It's resource utilization. I guess that the other advantage that I could give you is that resource utilization is both a disadvantage and an advantage. Why do I say that? Because I can actually run a Windows machine right next to a Linux machine, right next to, whatever else would run on the architecture of the CPU that you're sitting on top of, right? That's the limitation. It has to be the same architecture. I guess nowadays they do have the ability. I did see something where you could emulate different types of processors, but that's going to be, you're not going to get near native performance doing that. I saw something about that, but again, for all intents and purposes, any operating system that you can run on your processor's architecture, you should be able to virtualize and put together a VM for it. So the thing is that it was resource utilization. They did this. They used to measure. Well, they do measure servers in how many VMs can I run on it, right? How many VMs can I run on it? And so instead of having like this right here, the bare metal, where you don't dare try to run certain things together, and they all could interact with each other. Now, if you've got a computer or a server, I should say, with like, what is it now? What can they put in there? A terabyte of RAM? I think I've heard some specs go up to that high, maybe even a terabyte and a half of RAM. You could, depending on the disk space you've got, you could jam pack that server full of full blown VMs. But again, nowadays, my understanding, I'm a developer, right? But I do absolutely love hardware and operating systems. It's probably one of the differences I find with myself and some of the other developers I've dealt with, is that I'm fascinated by all of this. And so the thing is, it really is about how many things can you put on one of these massive servers. So if you have the overhead of a complete operating system, and having to dedicate the resources to complete operating systems, then you really do you really do have a reduction in the utilization of that server. You can't put as many things on that server. And so let's kind of move on to the next iteration of this evolution here. And so it was seen that we really can jam pack a machine full of VMs, right? But again, like I said, the resource utilization of having to have the full operating system over and over and over again installed, in each of those VMs is kind of a waste if you don't have to have that waste. So one of the things that came around, and I think it was about 2013 when this was really released, and I think that Docker was the first time that it became mainstream. Let's talk about containers for a little bit. Now, I didn't use containers before Docker. And why did I say that? Why did I say that? Because most people here might say that containers may have not existed before Docker, but I would say go do a little bit of research on the complete history of containers. It's funny because, like I said, my father was in software development, and when I was explaining Docker to him, he said, "Oh, that sounds like jails." There were technologies in some of the Linux systems already. Yeah, yep, exactly, Dean. BSD jails, right? So when I described it to him and he came back and said that, I'm like, oh, okay. And what I found out is that there was the ability, even in the past, to create these, what's the term for it? These basically containered areas of your operating system, of your running instance, and the programs that were running could not access other programs that were running. You could create this isolation without having to have a full operating system. But Linux containers, well, LXC, right? So that was another technology that existed, before Docker. In fact, I remember this distinctly, that Docker was built on top of LXC at first. So, the thing is that they actually built on top of it. But what did they do here? Or LX? Yeah, yeah, yeah. I've played with LXD too, but remember, it's very raw, right? You have to configure everything, and that's what I'm about to show you. Is that with Docker, you don't have to like be a networking engineer to make it work, which is what LXD makes me feel like. By the way, I'm just in case anyone's watching from anywhere else, I am responding to some comments that are being put into the private chat. Just want to be sure and put that out there, because I just remembered that people might be watching this from outside of this exact environment. So, okay, well, let's talk about what Docker did. Why does Docker even matter if we had the container engines itself, like Docker, matter, since containerization kind of existed forever? I mean, when I say forever, it's been a long time that you could do chroot, or any of these things that would allow you to create a segment of the system, and try to create some isolation between different programs. But what Docker did back in 2013 is basically they said, yeah, Dean, Container D is, I think that's relatively new, right? Yeah. Anyway, but what Docker did for us is that they gave us like the first time that we could just walk up, and they gave us structure. They actually gave us structure. Let me put it that way. It was a structure and process. So now, instead of having to go and run all these commands, maybe Google for a bunch of things, and get all of that put together, Docker gave us a really concise way to start creating containers, and to make them usable as quickly as possible. They abstracted away all of that stuff that was underneath the covers that you would have to run by hand. So if anyone ever wants to know kind of what it feels like, look at LXD or LXC, and look at them directly, and try to get networking to work. Because I've been there, I've done that. I've tried. I've tried. But it wasn't exactly, I think I finally got it to work, but it was absolutely not a love story in the end. I'm just going to go use Docker, y'all. That's what I'm going to do. That was my thought. Another thing, though, I want to be fair. Docker is not the only container engine now out there. There are some other ones, like, there's Rancher, Podman, just for like base container engines. And yeah, so it's just Docker's what I started off with. Docker's what I started off with. So that's why we're talking about it today. Okay. So let's just say we've got containers now. We've kind of talked about the fact that what did Docker do. As we run maybe through some of the demos, I think we're going to see like maybe some of the advantages of Docker. I don't want to just like say them all here, but Docker, the main points of what Docker provided is they provided a really slick way of being able to um, get our containers. So they provide a registry of pre-built containers that the community has put together, and maybe even Docker themselves. And we it's just such a vast library of containers we can get now. And I'll show you kind of how that works in a minute. But then on top of that, the way that they made it to where the file system works for it. So remember what I said about how each time we have an operating system, each virtual machine is the full operating system. Well, with Docker containers, first of all, you don't you're not going to take up all the storage for the container. They use what is called a layered file system. So you'll see that when we get ready to start building some containers too, is that in essence, when you pull a container, it's one layer. And then when you start adding your stuff onto it, you're only adding your stuff to it and not the entire container at one time. Now, the other advantage that we get with a container engine like Docker is that there's still isolation, but it's using the kernel, the operating system's kernel directly. The programs are running within that space. They're not running in a completely virtualized computer at that point. You can control things like how much RAM a container is allowed to use up, right? You can control things like how many CPUs they're allowed to access, but it's not going through a hypervisor at that point. It's going directly to the kernel. And just in case anyone's listening that saying the kernel is a concept that maybe not everyone has in their head, just remember that the kernel is the layer that it provides. Programs will talk to the kernel, and the kernel will actually handle all of your hardware operations like scheduling and stuff like that. It's the thing that handles the hard stuff that we don't have to worry about when we write software. It's abstracted away. The kernel does a lot for us. All right, cool. I think I've talked now for about 30 minutes. So what I want to do before we jump into any demos, which is where I'm heading next, are there any questions, comments, or anything out there from the audience?
I can ask a couple stupid. Oh, sorry, Dean asked. Yeah.
Mine was dumb. It's all right. Keep going.
Okay. Like I said, I wanted to stop. I see the analogy, the metaphor that you left there, and I want to take a chance. I just haven't had a chance to really read that and ingest it. But let's see. Oh, I don't remember that. I don't remember that episode.
Oh, okay, it's just a cutaway, but they go from like one side of the earth to the other, and there's someone in the middle like doing all the little like pistons and everything. I'll see if I can find a URL. I thought you would have recognized it.
No. And I've watched a lot of The Simpsons. It's just it's been going so long that I don't usually I don't catch every episode anymore. But
it's in the one where they visit Australia. That's why I remember it.
Oh, I'll totally take a look at that. But okay. So I think I think at this point, what I'd like to do is kind of demonstrate Docker a little bit and see and just give you an idea of the power and hopefully reduce a little bit of the confusion around it. So what I'm going to do, I'm going to minimize this private chat. Well, no, I'm not going to minimize the private chat because I'm just going to take a look at my screen. I was trying to look at my screen through the.
You just press a small arrow at the top right.
No, I know how to get rid of it. I just want to. I want to keep it available though. If someone tries to tell me something, that's why I was. Anyway, this is the first time I've actually done a presentation on this platform, so it's all good. It's all good. We're good. We're good. Okay, so let's go ahead and take a look. So right now, I am sitting on my bare metal, right, and I'm actually running a program technically on the bare metal Visual Studio Code. Let's go ahead and start taking a look inside a little bit, and let's get an idea of a couple of things. I have one folder here right now. This is probably the simplest example of a container because I don't want to go too far into the weeds real fast. So we're going to do a couple of examples here. The first one I want to do is let's just talk about maybe how we run Docker. By the way, I'm not going through a full Docker install. I don't think I need to, but if you want to install Docker, you can Google Docker and basically it should be docker.com anyway. If you want to go there, it'll be docker.com.
I usually point people to get.docker. You know how
then let's go there.
Yeah. I'll see get Docker because it's just a script that they have.
Yeah.
There it is. Yeah, if you go, it's just get.docker.com. If you go there, it'll have a script that you can use with your terminal and it will install it in one hit.
That's great. That's awesome. I didn't even know that existed. Because there's two things for installing Docker, right? If you want to run it as a developer on your desktop, then that Docker desktop is usually the way that I go with it on like a full blown like Mac OS. I have to. There's no option around it. I can't run. I need Docker desktop because they handle the fact that Mac OS cannot run Docker natively. But it's really good though. But as far as if I'm running on a Linux box, usually what I do if I'm standing up a server now is I'll go to DigitalOcean and I'll say, give me a droplet with Docker on it already, and I don't have to go through the setup and the security configurations and all of that stuff. So I try to avoid being able to make those kind of mistakes, right? Reduce foot guns.
Are you familiar with Cloud Init?
No.
Okay.
I've heard the words before, but I haven't had a chance to look into it.
Cloud Init's what you can use when a default Linux server is booting up. You can give it configuration without the need to have anything on the server. I know you were talking about hardware earlier. If we wanted to configure bare metal hardware without actually having anything on it, that's how we do it.
Okay. I'm gonna look into that. That's a really good point. I've heard the words before. It's just, and I may have even seen it somewhere, as in trying to set something up or someone setting something up that they've used that. But those words definitely spark, like I've heard them before, kind of memory. But yeah, I'll definitely take a look into that. I know there's some other technologies too that kind of will get a machine into the way that you want it. I was thinking, back in the day, I had a chance to play with like Puppet and Chef and stuff like that too, that will get a machine into the state that you want it in and keep it in that state, which is the important thing, right?
Well, the scenario that we had is we had a bare metal server going into a data center that we weren't going to be able to touch. So we knew which port it was going to be connected to. We knew its MAC address, and we had to do the rest externally.
Yeah. That makes sense. Okay. I'll absolutely thank you for pointing that out. Maybe that's something I could use quickly on a server. But for me, the easiest thing and what I would recommend for most people that want to get would want to deploy a Docker server of some sort is is something that's already kind of pre-built. Like go to DigitalOcean and do a Docker droplet, or there's a bunch of other ones. I just always have DigitalOcean in my mind because that's what I've used a lot to do that. I want to be careful though, because I see that we've got one more person and it squished my screen down a bit. So I want to be aware if people can't read read the text on my screen now. Just let me know. Okay, let's go ahead and jump into a couple of demos. And the fastest demo, after you have Docker installed, the first thing that you're going to do to run it, you run the Docker command, and you're going to get a bunch of help, right? You're going to get a bunch of like, hey, run this to do that. And it's going to not make sense because you probably have just run Docker for the first time, and that's okay. But just know that there's a good help system in there. Oh yeah, I mean, yeah. I'm not going to go through the full configuration in this call. I just want to kind of go do an overview of it. We can go more. Hey, if y'all want me to come back and go more in depth into Docker, and we can talk about some of the more in depth things, then we can. It's just I kind of meant for this to be an overview of Docker itself to try to reduce the amount of confusion people have around the whole concept of containers. Dean, I do appreciate the prodding. You've brought a couple of really cool things up that I thought about. So you're cool. You're cool. All right, so let's keep going here. To run a container, the first thing that we can do, and the first thing that I think the Docker documentation tells you to do, and this also tests to see if Docker is really up and running, is if we say Docker run, and I believe it's a dash, hello world. There we go. This is the first container that you usually run in an installation. That just tells you, it gets this really tiny container that all it does is, give you this hello from Docker and might give you some steps to follow and all of that happy stuff. But again, we just ran a Docker container. End of demo. No, I'm just kidding, I'm kidding. I guess the main thing that the part that you might not fully have yet is that the Docker command itself is what we call a client. And there is actually something called the Docker daemon that is running in the background that is controlling all of Docker. It's what all of these commands are running against. So if I were to write Docker PS, if you've got a lot in the terminal, PS is a way of getting a list of things running on your computer. This is basically from my own user in this terminal right now. But or my own user, I should say. But PS gives us a listing of running processes. So Docker has its own PS. I run that. Well, we can see that I actually do have some containers up that I didn't realize I had up and running. But this lists all of our containers. But again, the Docker command itself is a client. And it's talking to this background running process called, the Docker daemon. And that's what's sending back the information about what's running and everything. We already saw how to start a container, which was Docker run. I've got some things that are running that I don't mean to be running. So I can actually say, Docker stop. It's gone. Later on, I'll even have to remove those containers, right? Because they weren't started with they weren't started in a way that's going to remove them automatically. But we'll go a little bit further down the process here. Okay, so we have these containers, right? But we want our own container at this point. I was just doing some experiments with another, with something else going on. I mean, I guess if you start looking at the names of these, there was a Redis server running as part of this group of containers. There's a Postgres server running as part of this group of containers. By the way, y'all, I don't have any of these installed locally. So the fact that that this group of containers wanted to have these, it pulled them down as containers. And I guess that brings me to the next thing. So in order to create a container in Docker, we have to specify how we want the container created. And they give us a language that we can use to do this. And we create a Docker file. And this is a very simple Docker file. I just really wanted to start simple and be sure that we kind of just walk through this and have a good understanding of containers, of basically how we would create a container. I've got an extremely embarrassing simple Python file here, right? This is another hello world. I do happen to have Python on this computer, but that's okay. Maybe I wanted to, run Python in its own environment without having to worry about any of the other things I have running on my computer. Maybe I want to be able to send this Python application anywhere around the world that has Docker and let it run, right? That's the things that I can get from creating a container on this. So, let's take a look at the Docker file itself. All right. Now, the first line here, the first instruction that we see might already have your head scratching. From Python : 3. Okay. Well, where is this coming from? What in the world is this thing, right? Well, guess what we get? And I alluded to this before. I'm going to jump out of the code editor for a second, and we're going to go to a website, and don't worry, I'm just going ahead and preloading it. Let's bring that down there. I'm going to go to Docker Hub. Okay. Docker Hub is a Docker registry that has a ton of containers. And I say a ton, that's an understatement, but it's a ton of containers. How many people have actually posted hello world? Well, guess what? We can search the registry and find out how many people have actually posted a hello world container. I mean, it looks like there's several of them, maybe even from some major projects. But I guess the first thing is, remember when we ran Hello World? Let's take a look at that. This is the container that we ran. When we said Docker run Hello World, this is it right here. Now, I realize we're getting kind of we're at like 47 minutes. I want to be mindful of time. What is our time? Do we have time constraints? I didn't have that when I first walked in.
Honestly, I think no. In terms of well, of course, there are some. Maybe we can have only some, how to say, a technical common sense, but other than that, it's like voluntary, and everyone who can time and desire can stay. If someone has some urgent business, he can watch recording. So I think we are free 1 hour, 2 hours, 3 hours. As you know, sometimes Bruno declared like 2 hours meeting and took like 4 hours. It's no one complained.
I've been in those, and I might have been the cause of those.
Yep. So.
All right. So, okay. We'll talk through this for a couple of minutes, and then we're gonna go back into the code, and we'll create a Python container and run the program. But all right, first thing is that we've got a really massive data source for containers. It's a massive registry. The first container that we ever ran was called Hello World, and it wasn't magic. It's actually on the hub in the registry, and it is right here. We said Docker run hello-world. Now, the cool thing is that at this point, what we should be able to do, what I'm hoping that we can do, is get the actual output itself. No, the actual Docker file itself. I wanted to show you that it's actually a pretty simple. It's a pretty simple Docker file. Usually, there is a GitHub. Is there another one? There it is. So again, Docker files. They're code. They let us create an environment really quickly. And in essence, just ignore all of the different CPU architectures. They just want to be sure it runs everywhere, is what they're doing. I guess that's an important point. Is that CPU architecture is a deal. I learned this when I bought my M1 Mac, and for the first time ever, I was off of Intel CPUs. When I first got my M1, nothing worked. It was a disaster. But let's go take a look. It can't get much simpler than this, right? But this looks really familiar. There's a from and some kind of word here. So we're using something as a base, right? We might be using a command called copy, which means we want to copy a file, and then we'll run that file. But let me show you exactly kind of how that works. So let's go back over to Docker Hub. I'm going to back on over. And let's search for Python, right? Because remember, it was Python :3 that was sitting in this file. From Python :3 was our first command. So what we can see here is that this is also an official image, right? It's an official image, and that it has all of these tags. That's a concept I'm not going to go too far in depth into right now. But I mean, we can directly ask for a container that's kind of like feels like an operating system that already has Python installed. Guess what? For all you Java people out there, you get the same thing. For anyone who wants to run .NET, you get the same thing. They all exist already in the registry. Every community usually pushes their containers up here. So for me, Python seemed like the simplest demonstration instead of trying to do like a Java demonstration. But it's all up here. And usually what will happen is if you scroll down, first of all, pay attention. Be sure that you have a supported architecture. Most of them have this listed. Is your architecture supported or not? Keep going down. And, we don't need to know what Python is, but here we go. How do I use this Docker file? Or how do I use this Docker container? And they tell you already things that you can do to use the container. In fact, this is exactly what I did when I put the demo together. I went and found this, and I used the example to put a simple Python demo together. It can get as complex as you want and be as simple as you want. Okay. So it comes from somewhere. It doesn't come from nowhere. In fact, you can even create your own private registries if you want. GitHub offers them. AWS offers private registries. Yes. There we go. I should have realized that. I did that with my VS Code. So, okay. So basically, again, this should look really familiar. It's the same example that I used. I modified it a little bit to make it work in my situation. I don't have a requirements.txt or anything like that I need right now. But this does show you how you could make, if you had dependencies, how you can get the dependencies put into your container and all of that stuff. And the same thing works in the Java world, and the same thing works in the .NET world. We all have dependency managers. And we can pull our dependencies in and run. There's some more complexities in there that I don't want to go into right now, but it pretty much is this. So let's go back to VS Code. If I just click there we go. All right. Here's what we got now. What we're going to say, and this is just a basic overview. We're going to use that Python image. We're going to say that we want to use version 3 because that was an available tag. That gives us I believe that gives us the latest stable version 3 Python that we can get. Within the container, imagine in your mind that there's an operating system that's coming up online for you, and you want to go into a folder and start doing things. So you're going to type in like cd space and some path inside the container. That's what this does. That's what that's what this does. It CDs within your container, and then now you start giving it instructions. It changes your working directory within the container. Now, if I had a requirements.txt, then I could run this copy command, and it would copy the requirements.txt from the local folder outside the container into the container. And that's a whole different topic too. Like we talk about contexts and stuff like that. But like I said, I want to keep it simple. And then also the next thing would be if I had that requirements.txt, I would run a pip install and have everything in my container before I did anything else. Then I'm going to copy all the contents inside this folder. That's what that means. Copy dot. That's from my side, right, from the host, or from the working folder where I'm building from, into the container at the working directory. And finally, this is the specification that shows when someone says Docker run with your container, this is the command that will run. Okay? So that's kind of the steps here. What's really cool, remember back when we first got started and I talked about layers? Most of these commands are layers. This one is not. The workdir does not create a layer by executing workdir, but copy does, and running this does. And what's the advantage to that? Why does that matter? Well, this is one of the really cool features of Docker I was talking about earlier, which is their layered file system. Since each one of these are layers, when we build this container, if the requirements text file doesn't change, it doesn't rebuild the dependencies. And you start up really fast, right? Let's test something here. Now, I want you to think about something. In VMs, when we used virtual machines, it's a whole computer. It's a whole computer booting, which means you have to wait for a whole computer to boot up before you can use it. That's Dean, I got your comment. I actually didn't want to go that far down the rabbit hole. Wait, Dean,
sorry about that.
No. And so what Dean asked about is that, hey, is there a way? I alluded to this in the past where I said, a little bit before where I said that building versus running, and I didn't, that I kind of alluded that .NET and stuff like that would be a little bit more advanced. And yes, you could even do the same thing with a build with the directive that you showed me there. But I didn't want to get into that right now because I think, we got to be mindful of time. So, I can always come back and we can choose an aspect and I can go as deep as you want in that aspect. I'd be more than happy to do that. And there's a lot we're not gonna be able to see today too. So I would love to do another part to this. So, okay. Let's go ahead. Again, before you stop me, I was talking about startup time. Containers come up really fast and they go away really fast, which is a little bit different than having full-blown VMs, right? So let's go ahead and start running some commands here. Now, we saw Docker run. We saw Docker stop, right? We can run a container. We can stop a container. Well, let's build a container, right? We're going to do Docker build -t. That's going to tag it. And I'm going to say run. That dot is extremely important. People that I've worked with when I first showed them Docker don't see the dot. So I'm going to zoom in. Well, I'm just going to really call the dot out, right? That dot is very important. And what it does is it says, where is the context that you're building with? And what that means is I'm building from within the current folder. So if I run this, new mistake. Guess what I did here? This is a good point, right? you got to be in the folder with your Docker file. There's no Docker file here. I need to go into the folder with the Docker file, then run it. All right. So I guess what we saw here is that I had already built this container. Dean, that's a really good point. It really is a lot worse if there was a Docker file in there and I ran it and I thought I was in the right place and then everything just went sideways. So I'm glad that I wasn't in a directory with a Docker file. Okay. So again, this container built like within, it says 0 seconds at the bottom there. It built really, really quick. Okay. Let's see if there's anything in here that we want to look at. Now, what we see right now, we're saying it's going through all the instructions from Python 3 and, it changes the work directory and it's copying. It says all of this stuff is cached, right? I could obliterate my cache and we could watch it have to pull all the, pull the layers down and all of that stuff, but I don't think we have to. I mean, unless you really want to. But we built it. We have a container image now. It's not a container, like it's not a fully, running container. There is a container image running. So I guess that the next thing that we would want to do now that we have the container image put together is we want to start that container, or we want to run that container, right? We want to actually see Python run. So let's go ahead and do that. And we're going to use another command, docker run. We used this when we ran hello world, except there's a couple of more points here that we didn't have before. We're going to say the --rm means that when the container is done running, get rid of it, right? Don't just leave the container up and running. When, we're going to give it a name. If you don't give a container a name, it's going to give it something weird from a dictionary of, 2 different names, like, jumping jackalope or something like that. It's going to be ridiculous. You won't know how to talk, you won't know how to access it, completely. And then what we're doing at the end is telling it, hey, use this container image. And we built that, right? That's what we called it. Python hello demo. Python hello demo. Those 2 match, and name can be anything you want it to be. I just usually want to have it something that I recognize, right? So if I run it, I mean, it doesn't do much, but what I want you to think about here is that what if I had to put a VM up to run that one command? Like, then you got like 10 gigabytes, maybe a gigabyte of RAM, or maybe you're going to be really adventurous and just only give it 256 megabytes of RAM. And Dean's nodding his head, being real adventurous. You could probably do a little bit of that there. But then, yeah, IoT, absolutely. I've done some stuff with some pies. I totally get it. So we ran the container. It ran hello world. That's all the Python script was going to do. It exited and the container finished running. It's kind of lackluster, but it was so fast, right? That container came for a second, did its thing, and went away. That is the opposite of a sandcastle, like Dean put it earlier. And the thing is that you can do that with your applications. You can do that with different server components. Like you want to run a database container. You want to run a web server container and all of that. It's all in there. But let me show you one more thing that I have in mind for this. Now, how do we even know it's a real operating system? Maybe I'm just faking y'all out. People who have never seen Docker before, and they're like, that was just a script you ran, and there's no operating system or anything like that. Well, I have a way to prove that. I have one more command that we can run. I make a couple of adjustments here, and I say right after run that I want an interactive terminal. IT. That's important. If you only specify one, it does weird things. And I used to always just go as it. I just used to call it the it switch. That's what I would call it. Um, that's how I remembered it. Dean, you were saying you did .ti. I just remembered it as -it. That would give me my terminal. But also I have to give it a command to run because it's still going to run. If I run this, it doesn't care. It just does what we told it to do in that initial command. So now I have to give it something to override with. Let's just try this bin bash thing here. Bring up a bash terminal. Hey, look at that. My prompt completely changed. Hmm? You know? So now this is the part of confusion that I've seen people get into, especially when you're saying, hey, your development environment is going to be within a container, is that they don't know where they are anymore. They start to lose track of, am I in my main system? Am I in the VM or am I in the container? And then I have to come back to them and say, now you can be in 3 different systems. You better pay real close attention to your prompts. Dean, that totally is correct. But the problem is that as a developer, I need to be able to teach people that, right? I don't expect them to come in understanding OSs right off the bat, especially if they haven't dealt with containers. So, but yeah, I mean, I spent all my life in not in containers, in operating systems and doing weird stuff. I was one of those reinstall Windows 95 every 3 to 6 months because I got mad at it. That's why VMs were so cool to me. That kind of thing. So I was in that camp, but most people aren't. I met developers in the .NET world back in like the 2010 time range. I don't think it's so much anymore, but in the 2010 time range, that they were young enough, they never saw the terminal. They never saw a command prompt. To show them they could go in the command prompt and type dir, I was teaching them something. And I'm okay with that. They were juniors, but they could do all this without ever seeing the terminal back in those days. Now you can't. But again, pay attention to the prompts. They changed. First of all, I'm not root on my Mac operating system, and the colors changed and everything. But now we can see that we're actually sitting in some other place, and we're sitting in the folder that we specified, right? /user/source/app. If I do an ls, we're going to see that we have the Docker file here, and now they're completely disconnected, right? If I could go into hello world and I can type in, let's type in hello world and put punctuation, right? And let's case that. And then if I saved it, and then if I cat out hello.py, it still says the same thing, right? Because they're disconnected at that point. We ran this copy instruction that copied the file into the container image. So again, we can actually go into this little operating system that we've got. It's minimal. I mean, I don't think we can do a lot in here at this time, but I think it's really a good demonstration of the fact that there are different layers that you're in. There's your host, there's the container, and all of that. So let me go ahead and exit. Actually, let's do something here. Docker PS. Oh, that doesn't look so good. But we can actually see the Python demo's been running for 3 minutes. If I exit now, it's gone. Just kind of showing you. Again, Docker PS to get a list of your containers that are running. If it ever gets stuck, you can always run Docker stop. I will for this one. And by the way, one other little tip. You only have to give it the unique first characters in that hash that it's got up there. So if there's nothing else that starts with 4E9, I can just type 4E9 in, and then the one that started with 4E9 is gone. That's a little tip there. You don't have to type the whole thing or copy and paste the whole thing. You just type the first characters that are unique for the containers that are running. Anyway, that was kind of a really simple, let's get a container up and running. One other thing I'm going to show you today is kind of that power of being able to bring components down where we really in the old days, and I've set servers up before where I had to put an HTTP server, like Apache or Nginx. It was Apache back in the day, but Nginx seems like what all the cool kids are using. I mean, when I say that, it's been a long time. Nginx has been used a long time, so I always feel old when I start thinking like that. But no, the thing is that we used to really have to go through a lot of hoops to set database servers up, to set up. Oh no! See, I just heard that for the first time. Don't do that to me, Dean. Dean just said that Nginx is on its way out. He's going to have to tell me what the next one is, so I know what to go look at. Anyway.
Well, I don't know what they replaced it with, but Cloudflare replaced Nginx because they reached its limits and they had to build something else.
Makes sense. Okay. So let's kind of keep going with this a little bit. So what if I want to run Nginx, right? Well, remember that I said that there was this really cool, let me not do that. I'm trying to get to a different instance of my Chrome, and I'm having an issue with that. There we go. One from there. There. Got it up here. All right. So I want to run Nginx. Well, can I run Nginx? Well, if you go to Docker Hub and type in Nginx in here, just Nginx on its own, it doesn't have any of these other, it doesn't start with anything else. So if I click on Nginx, that's an official build. Now, this is really important. I want to say this, and I want to say it loud. Well, I'm gonna actually say it quiet and come into the microphone and just tell you this, right? So here's the deal. This is important. If you're gonna run something as important as Nginx or MySQL or Postgres or anything that you're relying on to be the right thing, you really want to try to find official images. Because if you don't, then you're getting whatever someone else created. And if you don't trust them, do not run it, because it's the same as running untrusted software on your computer, especially if you're going to throw important things through it, like make it part of your infrastructure. All right, NPSA here. So we do have a Docker official image of Nginx. And if you scroll down, we can get the instructions, how to use this image. And there's some things that we can do. Now, I don't need to set up a full server right now, but this gives you basically a good little Docker run that you can run that will set up with a folder, we haven't gotten into volumes. We're not going to have time to do that today. But that volume is just a way to be able to mount some external storage into your container that is persistent. Then you just happen to have Nginx up and running. And it works like this for MySQL, for Postgres, and any other major component that you could think of. I think there's even one for SQL Server sitting up there. We were talking about Microsoft Shops a little, the fact that I came from that background a little while ago. Even there is, if you can think of it, it probably has a container out there. Okay. All right, so let's just demo running Nginx real quick. So I'm going to throw this over here so I still have it there. And if I come into my terminal, let me delete that or close that tab. And let's just come in here and run this command. Okay. So we've got a couple of new things here, right? Docker run is still with the --rm. I'm going to run it. I'm just going to see all the output that it runs, but there's also a way that I can tell this to run in the background. Well, I may actually show that too. But what it's going to do is we're specifying a port mapping. Now, this is one of those things that trip me up a lot. On the left-hand side, it's your computer. On the right-hand side, that maps to a port in the container. So it's from left to right, like your computer to inside the container. I don't know why that tripped me up, but I wanted to say it a couple of times because of the fact that it did. When I first got started with Docker, I couldn't remember what the order was supposed to be for some reason. All right, and then we're going to run Nginx. Right? If I hit enter, Nginx is already up and running and didn't have to do any installs. Now, if I had cleared my cache, you would have seen it may have taken on my connection a few seconds to bring down the images. But this is a full-blown application up and running. Can I prove it? Absolutely. So if I bring this over here, and we go to, we said 8080, right? Local host 8080.
Is the reason you had to specify the port that way because you're already running something on port 80 on your machine?
No, it's typically that I don't run personally on my computer. I don't run things on ports that low. Like I just usually don't do that. So I leave them at higher ports. Yeah, but because I may want to run more than one web server too. Like that's the other thing, because I may have more than one thing going on that I want to have access over HTTP to it. So it's a habit of mine. I mean, I guess we could have run it on 80. I don't think I have anything running on 80. Let's see. No, I don't. So what happens if I do say let's run it on 80?
Does Mac let you run it on 80?
That's a good question. We're about to find out because I don't try. So the reason why, Dean, that was you, right? The reason why you asked that question is that typically operating systems get a little finicky about you trying to run programs on ports, lower ports like that. They want you to have elevated rights to be able to run that.
There's another thing I noticed is some projects that will have a script instead of getting you to do the Docker part itself will already have the ports defined. And I've had people come to me because they didn't know how to get around that part. They didn't understand what was going on, and it wasn't in the documentation or anything.
That's a good point. And I actually really wanted to have time to go over it, but I know that we're about 16 minutes over time right now, so I'm not going to go into Docker Compose today. That's actually probably a whole session on Docker Compose would be necessary. It would just have been a really cursory overview of it. So let's come back into localhost and see if I just change the port. All right, it does let you do it. So I restarted it on port 80. Again, now I stopped it. I just want you to see this because y'all might think I have Nginx running in the background somewhere. I don't. I stopped the container. It stopped responding. So let's take a look at something. One more thing that I wanted to specify. I'm going to go back to 8080. Again, remember the left-hand side is your computer, and the right-hand side is on the inside of the, where you're going to on the container. If I specify, I think it's right here. Check that out. So what I just did is that -D that I added in there after run, told it to run as a daemon or in the background. That's really -D that's how I remember it as a daemon. But it tells you to run it in the background. And now we got this hash back instead of getting all those logs. Now let's go back here to prove it's running. 8080. Boom. Still up and running. And I can go off and do other things that I need to go do. Or if it's time to actually kill the thing, I can say Docker stop, and probably could just type in F61E. And now it should be stopped. So that's another way. If you want to run it in the background. Oh, I do have something already. That's interesting. That's interesting. I just learned something, y'all. It overrode the port. Usually you can't do that.
I've never seen it do that before. It usually errors at me.
But I think I don't know. I don't know. I've never seen that before.
It
I had
must be a
something
new
else.
feature or something.
Yeah, this is just HTTP server running on my on 8080. I didn't realize I had anything running on 8080. But anyway, Nginx, I can get Nginx running up almost instantly, and it works the same for database servers. And man, have I spent some time bringing up databases. So I think the main thing is that we have this way of creating, bringing down these components, having them instantly available, and the other part of this too is that when we do go into Docker Compose, I can show you some really cool stuff where we can create an entire environment with one file that abstracts all of these Docker commands away. We run Docker Compose and we just go, up -D, and everything you specified in this one file is up and running and can talk to each other at that point, which networking is another component we didn't go into today because there's a lot to do. I mean, there's a lot to go in with Docker. It's a really advanced topic. So again, I guess really to recap, I'm pretty much at the end of what I think we can demo and what we can do today. Is that we saw the evolution where we came from bare metal to where we got VMs, and that really helped us with resource utilization. But again, we had to duplicate all a whole computers over and over and over again on a server. And really, when you're spending like $100,000 on a server, you want to pack as much as you can into that thing. And so, containers were another way for us to create these portable environments that we could move from one machine to another, and it uses resources so much more efficiently than a whole VM. There's pros and cons to both sides, but in the end, y'all saw how fast the container came up, and y'all know how long it takes to boot a computer. So it's so fast. I can start any, I can bring up MongoDB in a container instantly and never install it on my machine. I can do it with Postgres or anything. If I want them down, they're down. If I want to run 10 different copies of Postgres that are dedicated to the applications that I'm working on, I can. It doesn't matter anymore. I don't have to share, right? I don't have to share state, potential shared state between different environments that I'm doing development in myself. I think that this has kind of pushed us ahead a lot. I was so excited when I saw containers for the first time. I really was. I hope that you go out there and try to play around with it some. I hope this gave you enough of an introduction to at least know the words to search for and be able to get something going. Again, I would love to come back and talk about Docker Compose and maybe even go even further into some orchestrators where we can talk about Kubernetes, but yeah, that's pretty much all I've got. I'm going to open the floor up for any questions that people may have, and thanks for letting me come and talk.
This is so great, Nicholas. Never seen anyone who really understands Docker till this moment. Or by understanding, I mean like really coding the files. And I think one of the thoughts I thought purely from business point of view that we have to install a lot of different systems, and they have different business tools, and they all have very different installation instructions, like database connectivity and such and such and such, like 20 pages long simplified documentation stuff. And this way we can put everything which doesn't talk to the outside world, we can put it in the container.
Mm-hmm.
And then you only customize the external world parameters, I don't know, HTTP ports, whatever, and you make it 2 pages long installation, and it's probably also much easier to spot mistakes this way.
Yeah.
And Dean mentioned that we can containerize our whole systems. I would prefer to have like a stable system built of 20 containers, and different developers can build their systems from blocks they need.
instead of having 100 different systems containerized, and still every new developer will require a new system as a container.
I have something for that. I actually thought about demoing. There's a website out there called linuxserver.io, and they have a really expansive list of containers out there that are like those systems. They even have one called their WebTop, which is in essence almost an entire operating system that is running that you can get into through your browser. Like it's the entire operating system. It's got X window, it's got a window manager and everything that you can get in there. And you can use Ubuntu as the base or anything. And what's cool about that is that in the Docker Compose scenario, what you can do is you can add the database services into any of the database services you need access to, and that all becomes stuff that's accessible from within that container. Take a look at that. Like if you want to build entire systems, they have everything down to if you just want like an open SSH server that's persistent and runs, they've got that all the way up to that WebTop, which is like the full interface and everything. And there's a lot of cool options there. So I think let me.
Portainer was another one I mentioned earlier. That actually has support for linuxserver.io, and it gives you a one-click install for every single app that they have. So I used to use that before I knew how to code, basically. So before I could drive Docker properly, I was using the UI to install everything. But now I don't need it, but it's still a really cool sort of thing you can have.
So what are the links you mentioned, Dean and Douglas?
I just put one in there, which is linuxserver.io, and then Dean just put in there it's portainer.io. Portainer is an interface on top of all this. So it gives you like a really cool GUI that you can. I've seen people use Portainer in some of the content that I've watched, but I've never personally run it myself. It'd be really cool. And like I said, it's really, I do all my work. So I do my day-to-day work is spent in a container. What I've done is I've got this container that runs persistently all the time. And, I use Visual Studio Code, and this is at work. This is my work environment. I use Visual Studio Code, and I use its remote abilities to, in essence, act, from my native Windows and main machine. I in essence use it from inside the container, and it thinks it's sitting in a Linux environment at that point, because the way that VS Code works when you do use its SSH remote SSH extension is it installs a piece of itself into whatever server you're connecting to, which you can, since I have an SSH server running on the container, I can connect into it. Now, mind you, my volume is sitting outside the container so that, when, the weekend hits and they shut all my virtual machines down, I don't lose all my work. But also for backups and everything like that, it sits in a volume that goes outside the container. But it's really cool. I really do like working in the container, because it means that I can just take my volume with me. And I've had to do this. I've had to move machines 3 times. I've had to move VMs 3 times because we've changed how we're doing things. So it's just really, back up my volume, move it over to the new machine, start up the container again, and I'm back at work. No downtime at all. That's actually possible. I mean, you can create containers that have IntelliJ running in them and use Projector to get to actually get access to it, and it would be as if they were working within the container. Resource utilization, I've seen Projector crash because one of our developers uses PyCharm, and that was what he wanted everyone else to use, but they crash all the time within the container. So that's why I did VS Code going into the container instead of having Projector running running in a container that's projecting something from within the container out. I like to go the other way. I'm seeing. Okay, so maybe I'm doing this a little bit odd because I'm seeing statements on the private chat instead of on the public chat, and I'm answering them. So um, maybe Nikita, we could talk about some of what you're putting out there if you want to talk back and forth.
Yeah, basically, I'm just thinking aloud how to, because I'm always down like how can it benefit business, because my celebrity statement from Bruno Souza is that currently I'm thinking how to help people get jobs. So with Docker containers at work, one of the jobs is to go to your boss and say that, look, this we can install software a different way now. Especially it will be true for legacy systems because they will probably benefit most. And because when it's very hard to install, it's a very good chance to actually properly once make it containerized and refactor the container itself, and then people don't touch what is inside. I've seen this stuff. And second thing, which was mentioned, it actually was more like a joke initially, but not anymore, about IntelliJ container. I've seen companies doing that when they install software as packages. So due to security reasons, you cannot go and install IntelliJ or something.
Right.
So you have packages which you can install, which will have the specific version. And I also really liked your notion about being really sure where you download your Docker images from. So because I immediately thought that, if I don't see this green thing, probably the best idea. Sorry, it will be a joke, but just go to like Kremlin website and download from there. At least you'll have high quality viruses, not low quality one. Maybe.
If you don't, because anyone can push to Docker Hub. That's the main. I just wanted to be really clear that if you're trying to get Postgres, or you're trying to get you're trying to get Nginx, they're really base parts of your infrastructure. If you don't get an official image, then it's on you at that point. But because I said it out loud. I always look for that official image. Is that is the green the green badge on the image, on the actual image itself, because like I said, if you get this is my thought, is if you get like a compromised database server, then you basically just handed the keys to a hacker at that point. I might even be calling home and transferring all your data. So if you see the green badge, you know that they're verifying the sources of where everything's coming from. It's coming from the right people. Now, on the other hand, too, if you feel adventurous, you might be able to go in and find, look at the Docker file itself and see what they're pulling in. But I still don't. I would never do that. And I've been around for a long time. I would not do that. Now, the main thing, the reason why I said be sure you trust the person that it's coming from. Did y'all notice in that list that it said Bitnami / Nginx? I trust Bitnami. I run a couple of Bitnami images in AWS, so I know that they're legit. And so I would trust, if the Bitnami user organization exists in Docker Hub, I'm going to think that it's them at that point. Which, if it's not, that's a problem. Again, that's why I said you have to be really careful. It's like downloading anything off the internet. You have to know your sources. And just because it's sitting, what was the old site that we used to use to download software from? There was one collection of software. There used to be a place that you would download from, and even there, just because it said that it was, it came from this company, I wouldn't trust it completely. I would always want to go to the company. Torrents are a little bit more risky. I wouldn't have. Nikita, you said torrents, and I'm like, nah. Some dodgy site. Yep. That's right. Never do that. We got to really be putting some of this stuff in the public chat, just so that it's out there for people when they know that people are typing in curl and some script.sh from a dodgy site. That's that's a thing too. You really need to be sure if you're ever going to like just execute a script that you pull down from curl, that you know who you're pulling it from and what it's going to do. Always look at those. Always just glance at them and be sure that
I'm pretty sure our entire application at work depends on a shell script that's in my GitHub account.
as long
It's
as you
my
don't,
insurance to keep my job.
that doesn't work though. You think
I
it
know.
does.
I know
You
it does.
think- I know.
They
Yeah.
could replace it very easily, but I like to see it every time the build happens. It's like, hey, my name's still in there.
Yeah, they didn't cut you off. Yeah. All right, y'all. We got any other questions? No. I love
Maybe
discussion, by the way.
a couple really kind of maybe stupid questions, but on the right of brainstorming. First of all, what do you think? Is it still useful? Or how wide is area of using like virtual machines for now? Yeah, let's put one by one. That's first question.
I got that. Okay, so why would we want to use virtual machines still when containers are so dang cool, right? Well, there are some disadvantages to containers. Like there's things you can't run in containers as of right now. They don't. Uh, you're not going to run like if you have one container, you're not going to run another like database server inside it. Like it doesn't actually let you run services. There may be workarounds for it, but the last time I tried to just play around with like trying to run services within the container, unless it's the use of the container, it's a little bit confusing there. I'll come back and click on that for a second. But yeah, no system D, like Dean said. It has no system D in it, which means you can't actually have multiple services running. Containers are good for one thing. You do one thing in them, right? Sometimes, like with that web top deal that I was talking about, where you had the full blown X Windows window manager deal going on, that you can do multiple things in there, but in the end, you couldn't install a database server within there,
And
and you
that
would
they
have to have
tend
another.
to use they
Go ahead.
tend to use Docker Compose to drive all that as well. So
Yeah.
it's not really all in one. It appears like it's in one, but it's not actually in one.
Yeah. Yeah. I mean, so the thing is that they're good for one thing. You use them for one thing. So if you need to give someone a machine really to work on, and you want them to be able to do whatever they want in there, then you're going to give them a VM, right? What like I use VM still when I go to like if I go to DigitalOcean. So if you're trying to give out resources to people that need to, not necessarily like a DigitalOcean, but if you've got a team of developers, you may not want to only put them in a container. You may want them to have access to a full machine, so they're not, they don't run into weirdness of always being in the container without having an actual operating system. I still see advantages to it from there. Does anyone over here have like maybe someone else sitting on here might have a good idea for other idea of why we would use VMs over containers?
I just shared something there. I used to work with someone who used to be in IT and tech, and he knows how to use vSphere and that sort of thing, but he wouldn't have a clue if I gave him a Docker file and needed to get him to run something in Docker. But if I gave him an ISO, he'll be able to run that.
Yeah. Okay. That I get that too. But he could also have the full thing going inside the container situation if you use Docker Compose, because you would say you don't have to worry about anything that's inside all of this. Now that's unless something breaks. That's a whole other story.
Yeah,
But
that's right.
yeah, but here's a reproducible environment where you just type in Docker Compose up -d, and you have a full environment, all the database servers, everything is up and running, and you just hit this web address and edit in your text editor.
Yeah.
That is another way to do that. I get the understanding part. I do actually understand that too, but I would say that in that sense, I would actually want to teach. I would want to help teach the person. And see,
And
that's
it's a human problem, not a
yeah,
technical problem.
yeah, yeah, yeah. It's definitely so. I guess really the question I've got now. I mean, yeah, that's a really good question that was posed to me. Are there any technical reasons, other than the fact that outside of human issues, that we would want to have like full blown VMs again? I've got one. I think I've got one. I've worked at a place, and this is portability, right? If I want to send an entire system to someone that may even have containers in it, right? You can do Docker and Docker, but if I wanted to send like a whole system that I controlled, like a virtual appliance, to someone that had all of this complicated setup within that virtual hard disk, maybe I would go the virtual machine route, because it may even have Docker running inside the virtual machine. Um, I'll give you one that gets a little bit more down the rabbit hole, or I'll give you something that does. Docker and Docker is possible. You can run Docker containers inside your Docker containers because, we heard you like Docker. So that's there's the meme, right? There's a meme out there. It's like, yo, we heard you like Docker, so we put Docker inside your Docker so you can Docker while you're Dockering. Yeah.
Well, that's how a lot of the build system works.
Yeah.
When you got runners and that sort of thing.
Yeah. It's definitely a you can go down the rabbit hole as much as you want in that realm, but I still think that there is a use for someone has like a vSphere, they have some kind of virtual machine infrastructure sitting out there where you could send them a virtual hard disk and they could bring up this really complex environment that you fully controlled as a vendor. And I've worked for vendors. I've actually worked for companies that do this kind of stuff, right? They in the security side of the business, they really don't want people having the ability to go in there and do stuff. So they'll send them a VHD, or whatever it is, right?
That's where
Whichever.
CH root comes in handy if you need to get into those things.
Mhm. So basically, does that help, Nicola?
Yes, thanks a lot.
Okay. All right.
And the next question is like similar, but directed to opposite direction. It's maybe difficult to predict exact, but what is the general direction? Will will this virtualization grow next? After what will happen after Docker? Not in terms of exact name, of course, we can predict, but in terms of maybe
Containers. What's
yes,
beyond containers?
exactly.
So it's really hard to predict the future, right? That's a pretty difficult thing. I wouldn't have predicted containers when we had VMs. When VMs were the de facto standard, I wouldn't have been able to tell you that we're going to containers. So I would my instinct says that I want to say that containers might be the most micro, the furthest down we can go, the atomic, at the atomic level that we can go to as far as that's concerned. But if I ever said that, I bet you someone else like watching this would say, hold my beer and here's something else, right? So to me personally speaking, I think we've got the ability to run these individual programs. We can put them together in a way that composes them, composes these individual atomic pieces together. I don't see where I just don't have a way to predict where that would go next. Now, let me tell you where it has gone. So we've only talked about Docker and we've heard us talk about Docker Compose, but no, the problem is that there's actually another level to this, right? Because you watch me run Docker commands, and if I was running Docker Compose, you'd watch me run Docker Compose commands, and that gets very tedious at some point, because then the servers that you're running on, if something goes down, you better have scripts that know how to run all of your Docker commands that you need to run to get things back up, or you better have a good Docker Compose file, and it's going to all run on that machine, and maybe that machine blows up in a fire and you need to have another machine to put it on. Well, that's when the orchestrators come into play. So the most popular one is Kubernetes, and that's the next level where you basically give a specification for what you need running and how many of them you need running. So this is the containers I need running, and this is how many of those containers I need running. And then you give Kubernetes, you give it access to a cluster of machines that are available for it to put those containers on, and it will put them on there and start up how many you tell it to, and give it the resources you allow it to have access to, and all of that stuff. And that happens automatically once you specify the files. But I think that the main point of all of this is that it's configuration through code instead of configuration through someone gets on there and flips some switches on an interface, or someone gets in there and runs some commands to get it into that place. And that is that your containers are configured through code. And then also on top of that, the ability for where those, for the orchestration side of it, where they can go is code. It's all code now, right? And that's the main thing, is that it also opens up the opportunities, because everything is code, that you can then get into the process of CI/CD, continuous integration and continuous deployment. That's where the whole DevOps side of things comes from, is our ability to be able to orchestrate releases using that code. And that's really the power that came from it. So no, I would love to know where, I would love to have like a crystal ball and go, this is where they're going to go. I mean, as much as people might cringe when I say this, maybe the AIs control it in the future. I don't know. I mean, that's the only possible next step, and we don't even understand anymore what it's doing. As far as like, we don't have to anymore. We've abstracted away us having to understand the infrastructure, which me being me, in some of the arguments I just had at work the other day, discussions, I won't call them arguments, but I always like to have a good idea of at least one or two layers of abstraction below the abstraction that I'm using. I know a lot of y'all have probably heard of Venkat, and Bruno. Well, Venkat's always said that always understand that one level of abstraction lower. Sometimes I like two, just to kind of have an idea, because when things go wrong, I've had to go all the way down, not to the machine level, but I mean, I've had to dig a lot of layers down deep to get there, to figure out what went wrong. And so having the ability to understand and not have something abstracted out for you, like, it might actually cause me a lot of discomfort if the AIs were abstracting out my infrastructure too much. Yeah, but the AI, I think, is going to be a major component, and I think that's going to change things up. I mean, it's already been what they call a black swan event already when ChatGPT came out, and a lot of stuff happening around that. That's actually another topic I can come talk about, because I've been doing a lot of. I've written some custom code around using the API, and I've learned some things about ChatGPT that make the interface now make sense, that when it didn't before. And it makes sense to me now, because I've actually talked to their API directly through code at this point. So I can come talk about that at some point too, which if y'all want me to.
Sounds good. I did a talk on that last week, actually.
Cool.
I'm doing a bit of work with OpenAI as part of my day job and as part of projects as well. I don't know if you've worked with vector databases either, but I'm looking at the OP stack, which is OpenAI and Pinecone DB. Another one that's popular is called Weaviate as well.
I've heard of those, but I haven't really gotten into the vector databases
actually
yet.
I can do it all locally as well. I just don't have the best hardware, so it struggles a bit.
Yeah, that's the point, right? You got to have the super high end. I guess it's all in the GPU at this point, right? Yeah, you got to have the super high end GPUs that no one really wants to go out and spend their own money on.
Yeah,
that's
if you're ever a gamer, I'm doing what that is like. It'll run, but at the lowest settings. So
yeah, I have not. I haven't been able to be a gamer in a long time, so I haven't really.
Either of I. But
Yeah,
that's the way it works. Like I'm on the bare minimum here.
Dean, that's really cool. Maybe we can chat about
Yeah.
AI at some point, because I have been trying to utilize, instead of being scared of the AIs. I'm anyone says like, here's Chat GPT, I'm like, okay, here's my $20. Let's go at this. You're going to help me with some things now, and it's the
Yeah.
cheapest assistant I've ever paid for.
Well, it's been a game changer for me.
Yeah. Yeah. I mean, even now, I don't have to Google search for a lot of simple things where I just go, I need a command that does this, please. And it just gives me exactly the command that does what I asked for. I didn't have to read through tons of web pages to get there and try to piece it together. It did it for me. So, yeah, it's like having another aspect of it. Oh, we're getting off topic, but anyway, AI, I think, is the next place that infrastructure probably will go. In fact, at work, and I think at a lot of really large companies, they're already looking at AI to really help in different aspects of the company, like SecOps and then also infrastructure. Like, give me all the telemetry, and then you start telling me things that you can see. You get out of my telemetry, all of my monitoring and everything. Because I was going to write
for cost optimization. I've done a fair bit with that.
So cost optimization, that's cool. Yeah.
Yeah, because we're an AWS shop, so there was a few things there that we just didn't even think about, and all I had to do was dump it into a ChatGPT window, and it just pointed out, yep, this. I'm like, thank you.
Yeah. Maybe at some point, like I said, we could maybe we come on here and talk through it again, because there's some really cool things that I'm starting to be able to do with it. I hadn't even thought about AWS cost optimization though. That opens up some different parts of my brain there.
There's just so many different markets you could attack with this thing.
Mm-hmm. I mean, I wonder, like, I used to work in logistics, and we worked on a load optimization. So like, how many, what boxes to put into what 50-foot trailers, and, where they were going and all that stuff. I wonder how AI can handle doing load optimization, because it's really complicated to write, that by hand. It actually takes an engine. It took us buying an engine that could do some of that. And then even with the engine, it was complicated to get everything working with it, but it was a brute force. There was no AI in that engine.
Yeah.
So, man, that's some good stuff. Any more questions? I mean, did I answer the where I see things going next question? Okay.
Yeah.
AI. That's what everyone's going to say. AI.
Yeah. Even I started doing AI, and Mikol knows that it takes me time to pick up anything. But basically, we having these events every Sunday, and initially it started with like asking how everybody is doing, but it is so much more interesting because we know how everybody is doing anyway. We have Discord group, but it's so cool to find people like you. Mikol, do we have anything planned for the next Sunday, or is it free?
If I remember right, Dean, correct me if I'm right. I believe, Dean, yes, I believe you had an idea to have a discussion with another guy from yesterday, from last week meetup. You plan to talk about AI and Chat GPT and similar stuff. Am I
Cool.
right?
Yeah, I'm pretty sure that was just there as a backup if we couldn't get anyone else, because I can just keep talking for hours and hours. So that's
now we have-
I'm sure. We've
We
got
can do
another one
AI
like
actually,
that.
because
we
it's
could
quite
both
hot.
do it if you're around. Yeah.
And now we have Douglas as well. And I was doing some tutorials on AI, but from the other side, I'm more like practical person. I don't have a job which allows me to do these cool things, so I'm like
Cool.
and get paid.
We should get on a stream like this, and we'll try to build something.
Yeah.
Do it live on air.
I found some cool tools, like, for example, ChatGPT can debug code. It can show you where the bug is. besides writing code, I also like the ChatGPT. You can tell it to write an article in 2,000 words about a book. Because a friend of mine, she's a psychologist, she asked me to read a book which she read a long time ago, and to give her like an essence of the book. So okay, I'm still reading the book, but the essence is there. She's extremely happy. And another thing, which what is the name of the tool? 1 second. It's called Glasp. So somehow this tool allows you to make a description of YouTube video. I'm not yet fully sure how it works, because I think that actually it will just combine the notes I write as watching some video, but apparently it can package those notes and make an article from them.
There's
Maybe.
ChatGPT plugins. Not everyone has access to it yet. I'm still in the wait list.
Me too.
But yeah, that's how you can do that sort of thing with YouTube, or you can do it via the API. But the API is pretty expensive, so you got to be careful with how much you're putting in there.
Well, it depends on which part of the API. I mean, I hit it. I was playing with Auto GPT the other day, and I messed around for an hour with it, and it was like 80 cents. So I mean, it just depends on how long you let it go and what you're doing. And but the other thing too, don't forget, Bing AI is open now to anybody. So if you weren't on the waiting list, you can go in. Well, I mean, the nasty thing about it is you have to go into Edge. You have to use Edge to go to Bing, and then you go there and you can click on chat, and then you have access to Chat GPT 4 basically with internet access. Is what
Hugging Face has Hugging Chat up as well, which is an open source alternative. It's about 90% of what GPT-4 can do, but it's not the same. Like it's awesome, but it's not as good as ChatGPT.
Yeah. So yeah, I can come. I mean, if y'all want to do like I would say not a duo, but kind of a team thing. We can come back next week and talk some AI. I mean, I'd be more than happy to be there. I may not put a whole presentation together this time, but because I think it'd be like just us kind of going through some things. Maybe we could come up with like a sequence, that we would, some objective for it, and then we can try to put some stuff together for it. But we probably need to do that pretty soon for the objective piece, and then we can work on it throughout the week and try to get some kind of aspect together.
Take your time. If you need 2 weeks, it's 2 weeks. We can just discuss how the week went.
Yeah.
And,
yeah. See how it goes in the Discord, because I'm usually like with my job, I have to be there the whole time, but stuff's not going wrong very often. So I get a lot of time to research and do sort of little bits and pieces like that.
Yeah.
I'll be at DevOps next week. DevOps UK, volunteering, and spend my vacation on that. So probably I will bring something. So far I have only one sticker from Elastic I had for my talk last week. So yeah, I took the Bruno's formula and made a talk from it. So
it's funny. The idea for the application I have in AI is actually a direct competitor of Elasticsearch.
Well, they have many direct competitors, but
maybe they can buy me out. I don't know.
Well, with the state of current industry, is anybody at all getting hired?
Yeah, exactly. It's not that great, unfortunately.
For the first time in a while, I've had people telling not to go into IT because there are no jobs there, and I'm like, not exactly true.
That's fine. They can stay out.
Well, yesterday I was talking to my friends from Ukraine, actually, here in London.
Yeah.
Well, I have Ukrainian friends, she has Ukrainian friends. And so I was actually helping a few Ukrainians to get into IT. So, and I think it's a very good time to start, because the competition in 2 years' time will be lower because the market hopefully will be up. But the people didn't learn too much IT because there were no jobs. So it will be with like data. Probably it will be a bit similar like data science jobs. That in the beginning it was easier to get it, and then in the end everybody needed a PhD from MIT or something to start with for a junior position. So
Yeah. No, I mean, what I say about that is that I think that I don't think AI is going to take our jobs. I mean, even with Auto GPT being given instructions to create an application, it's still not. It's it's not great. So
Well, the way I see it is like we've had no code like at a pretty decent level for a while,
hmm,
and I've just found that most people don't even know what they want. So AI is just going to be a lot of the same there.
yeah, yeah. They'll need people to interpret what they're saying they want to give to the AI. It's just going to be a different kind of work that our brains still have to be used to get done, right? At the point where we're at now, what I really do have some concerns about is the junior levels of developers. You get someone like us where we've watched people ask us for things and it totally goes wrong, like that we give them what they want and then it's not what they want. We can start to read between the lines with that experience. People would have to be trained exactly for that skill and maybe not necessarily writing code, but still the computational thinking, like to be able to direct the machines. In essence, we would become managers of AI, of AI agents at that point.
And that's where my years of experience come in, because you can't just learn
Yep.
that out of a book.
Nope. You're absolutely right. A lot of intuition here.
A quick note. I just it's kind of funny talking about people who say that there are no place for it's nothing to do in IT in the future. I remember one friend of mine, of course, for kind of joke, but he relocated to a real great state in US, and when he was asked by friends from another countries like how is life in that state, no, it's awful, don't come here, no, stay where you are, not don't join me. So I feel like it's similar situation. Like no.
Yeah. I think we lost Nikita.
Oh, I even didn't notice.
Yeah.
Oh, that's probably it anyway. But no,
Yeah.
that was an awesome talk. Thanks for that.
Appreciate it. Thank you so much, y'all. I appreciate the compliment.
Yeah,
Thank
nice
you.
to meet you.
It's good to meet you too, Dean. It's good to meet all of y'all.
Oh, I'm going to drop off because it's like 2 a.m. here and I've got work in the morning.
Oh,
Well, no, I always do this every Sunday. I keep weird hours. I'm like, my best hours are from about midday until 2 a.m. So that window there is where I can get my best work done.
Dean, we're in Australia?
Yeah, Melbourne, Australia.
Okay, because we have a branch. We actually have people that work out there that I've had to interact, and so it's like 5 o'clock in the 5 o'clock in the evening is 8 a.m. the next day their time. So
Yeah. Well,
it's one of
actually,
those.
a cool thing about having odd hours, because I work for an American company,
Hmm.
and having odd hours means that I get to talk to all the important people. So all the good projects have come to me because I'm actually awake when the management's awake.
Yeah. Yeah. Well, anyway, I think I've got some stuff I got to go run and do today too, and um, again, I'll come back next week if actually I'll just come back. I'll just join in, and maybe I can be part of the conversation in
Sounds
the
good.
future. So I can make this one of my regulars, like the Saturday morning meetings I do, and then I can do these too. So
Awesome. Well, yeah, I'm always down to be building stuff or doing whatever. So
yeah.
feel free to message me.
All right, y'all. Really appreciate it. Great to meet y'all. Some of y'all I haven't met for the first time, but the ones that I have met for the first time, it's good to meet you, and also good to see ones I know again. Thank you so much, y'all.
so thanks
Catch it.
a lot for real great session, great presentation. And briefly speaking, as I noticed, I think definitely the topic of containerization is still not complete yet. So we can talk at least about Compose, Docker Compose, and Kubernetes, at least, right? At least two
Yep.
topics. And
Docker
yeah.
Swarm as well. Like it's always worth covering Docker Swarm, I think.
Yeah, I think so. I mean, so to be perfectly honest, it's always been for me. I didn't go through Docker Swarm. I went, it was Kubernetes. That's kind of the platform that I'm on, and it went straight from Docker Compose. So
Yeah.
I would have to go do some. I'd have to go do some research about Swarm and see.
Well, I know a lot about Swarm, so even
cool.
if yeah.
Then maybe we can ask you to talk about Swarm, Docker Swarm. Yeah.
Because I've a lot of my work is in Docker and containers. So like my current job, I actually talked everyone out of using containers because it made sense for our use case. We're a Ruby and Rails shop, and some of the tooling that we were using just didn't make sense in Docker. So yeah, but I have a lot of experience with Docker and Docker Compose and Docker Swarm as well.
That's cool. That's cool. Now, see, that would have been an interesting conversation to have. Maybe we go to the more advanced stuff, because I'd like to talk more about the decision not to containerize than even the decision to containerize, because that's a massive debate. Like, there have been companies that
it came down to human problems again. It wasn't technical.
Oh, okay. But I mean, human problems are really a big deal. There's a company that I know of, a friend of mine worked at, where they spent like a year and a half trying to go to containers, and the project failed, and they didn't.
Yeah. Well, I put together an awesome containerized version of our application now, and none of the developers want to use it. So where do I go from there? Like, I'm not going to be the guy that forces the entire team to use Docker when they don't want to use it.
No, if they don't want to use it, then they didn't ask for your help. Unfortunately, that's the realization that even I, that I have to come to at some points, where if someone comes to me and says, "Hey, this really stinks trying to put this together and get it up and running," then you can come in and bring in the solution for it. But if the team doesn't want to use the solution, well, there's another problem then, because they perceive that the solution costs them more than just doing it the way that they've always done it.
Yeah.
And that's the problem, and that's a real problem. Like, that really is a human issue. I don't know.
Yeah, what can happen is that we get pushed, because we're DevOps. We don't necessarily always come from the dev team, and sometimes companies will just hire DevOps and throw them at the team that the team never asked for in the beginning. Like, that's actually a common thing that kind of happens a bit. I'm lucky enough that I've been able to avoid it, but yeah, I've definitely seen it around.
Interesting. So I've, in essence, I really have done what DevOps would do, but I've never been hired to be DevOps. I don't know if that makes sense or not. So I would always come from I like that. I would always, come from the development side. I've thought about actually moving over into what my company calls DevOps, and then be like, okay, we're going to do real DevOps now.
Well, I was a systems administrator that was basically just getting into the start of code. Like, I wasn't even what you'd consider a junior, and I got thrown into a senior team that expected me to be a senior from day one, basically. So I had to get it, or I ended up getting let go from that position. But if they had have left me for a little while, I would have been okay. Like, that's how quickly I got up to speed.
Yeah. Yeah. I mean, so I think the thing is that if you can talk to, I would actually like to experiment with this at some point, because I think that sometimes it's just not sold. It's not marketed to the developers in a way that they, that it hits them. And I'm actually really shocked, Dean, because here's the other thing. It's so common now to not want to go through the pain of setting an environment up. And I had actually talked to a place at one point that what they actually had containers running so well that you made a branch and you got automatically everything set up for you. Like, their CI/CD would even set up the dev environments. Like, you need a branch. Once you created a branch, you would have an environment around your branch fully up and running that you could get into and do stuff with. So
our biggest killer was a tool called Bundler. Like, I work in the Ruby and Rails world, and Bundler is a tool that we have to use in our application for Ruby. And if you're running it in a container, there's no way to have the cached versions of everything. So these guys that are coming from a non-Docker background, everything works instantly. But in the container version of it, it takes like 10 minutes to be building. And there was actually no way to, with the architecture of the application and everything, there was no way of getting that time down at all.
oh, then you're never going to mark you. That's pain, right?
Yeah,
If it takes them longer, they'll never use it. It has to be. There has to be. It has to be a all wins or no go.
Yeah. And
right?
I'm so lucky that I was able to sell it to management for us not to use it, because the way our company is, I was basically directed to make this thing go in Docker, but I ended up coming back and selling not using Docker, and somehow I got lucky and they agreed.
The bundler thing is a real problem. I seem to remember having issues. There have been issues I've had with Ruby and Rails. I haven't done many Ruby and Rails projects, but there was something where where it just took forever. Every time I had to kick it, like I had to cause a restart, it was so painful.
Even better,
painful.
This application started development in 2011. So it's a huge Git repository. And
yeah. I've always wanted to go into, like, I tried at one point in my career. There was a company that did I typically call it Ruby on Rails. But they the thing is that they did it, and one of the things I just wanted to see, like a full like I wanted to see the pain of it, like when something, it looks really cool when you create your toy projects with it, just like Meteor.js. I don't know if any of y'all have ever used
I'm familiar with it. I've never used it, but I know what it is.
I actually built a whole, like, I went through many years ago and made like a whole blog series on it. It's gone now. You have to go to the history, the archive to see it now.
Wayback Machine.
The Wayback Machine has it. But I made a whole like series on it, and it's still one of those where it was really cool to build it, but I could perceive that once you got into trying to put an application together that needed to stay running and for like 10 years, what would this look like then? And same thing with Ruby on Rails. I wanted to see work in an environment that actually had been 10 years down the road in their Ruby on Rails project, so I could see what that looked like.
I think I've learned more in this project than I've learned anywhere else, because I've got to deal with a legacy application with that much history. And we've refactored so much, and just it's unbelievable the amount of stuff that I've actually got to work with here.
If you feel comfortable talking about it, did they properly, is it properly got like unit tests and stuff like that behind it?
Yeah, it's really well sort of maintained.
That's cool.
It wasn't necessarily when I first got there, but I've been there for nearly a year now, and we've been pretty flat out the whole time I've been there. So,
one thing I was thinking about when I said testing out loud, so another topic that I could talk about, I have a legacy code base that I walked into in Python, and I came up with a way to basically sandbox the environment very concisely, and so that and within the same code, right? Because in Python you can override the world. You can
virtual environments.
Well, no. But when I say override the world, you can become all it sees and hears. You can actually take and override the requests library, and
awesome.
You can take it. Yeah, and so in one place, instead of having to do like what we would have to do in some of the other languages I worked in, where we'd have to go and modify all over the place to try to get this to work, and because the code was so written, it was actually written very poorly. We really would never have been able to get to all the places in this code base to do what we needed to do. So the fact is, I found like a way to introduce at startup an environment variable that puts it into sandbox mode. And this one module runs that has very few lines of code in it, and it can override it overrides the requests library. Well, it proxies the request library and also proxies subprocess.checkoutput. And so, and I've also kind of overridden how, the database stuff too, just all from that one place. And so it is very sandboxed at that point. It sends a request out. I see what it is. I look at it, and I've got some collections of requests and responses. And if it matches one of my requests that I'm looking for, I can actually send back down the response without it ever touching the network.
Is that using like a HTTP man in the middle?
You would consider it man in the middle, but it's in my own program, right? It's actually part of the actual, it's
so behaving like a middleware in a way.
Yeah. I'm putting middleware in way of if it's of its primary and secondary ports. It's inbound and outbound ports, so that I can actually take over everything, and I don't have to modify any of the code that exists already, and I can start testing entire processes and make sure that what comes back out is what we expect. And so if anything goes wrong, then I can go debug it, and it's reproducible, and it takes seconds to run instead of taking 5 minutes to run, because it's just hitting all of my proxied, all of my proxied responses that I want to come back to it, instead of actually going out to the network. And because of the kind of work that I do, which is network automation, a lot of times the network itself has changed. And so I can't rely on the same data coming back at different times when I run. So I have to have that capability of being able to have a reproducible environment that my code can hit without, because I don't get a dev environment. There's no such thing as like a complete dev network. I don't think anywhere, but at the size of the place that I work at.
What about like a simulated network? Because I know back in the day, I managed to get my name in the source code of GNS3. Could you run it as like a virtual network?
Well, I mean, I guess that we could try to do something like that, but like I said, the thing is that technically speaking, it can't get out to the network. It can only receive what I tell it to receive.
Yeah.
So I don't think I really have to at this point do something like that. And it's such a small amount of code to make it work. It's just it's that Python is really Python. That's both a really cool thing about Python, and probably from like people with my background, it's one of those that makes me cringe too. So I have two sides of me. One side, I guess, on the shoulders, right? One side says, "Ha, that's great," and the other side says, "You really should just go back to Java or .NET, Douglas." But in the Ruby world, I think you can probably monkey patch the world too. You can. Yeah.
Ruby's very hackable. Well, I'm not I only started coding properly like a couple of years ago, but I'm picking it up pretty quickly.
That's cool. That's cool. All right. Well, I think we have a lot. There's a lot more stuff we can do, but I think I do need to run. It's getting we've been on here for a good while, and it's about to be lunchtime, and I've got 3 kids and the wife, and
all right. So I'll see you guys next time, I guess.
Yeah.
Yes. Thanks a lot, everyone.
Bye.
Cheers.
Thanks, y'all.
Thank you. Bye.